Hello again and welcome to this tutorial 2. The introduction of columns, walls, beams and slabs is shown in detail in the tutorial number 1. Hence, we will describe the additional steps required for the modeling of stairs and elevated slabs. So, we are in the building modeler facility, and we will start with the stairs. First, we click the Insert Stairs button. The help window will initially appear. You already know that we can disable these windows from appearing. And we see that in the Sections Properties window the Stairs Characteristics menu appears. Equally to the slabs here for the stairs, we will also need to specify the stair loads. Again, we can select the live loads from the ready-made list, containing the live loads for several types of areas as they are defined by the selected structural code. Or assign the values. Let's now insert the stairs by defining the stairs centerline. After we finish the definition of the stairs centerline, we select Apply to insert the stairs. We can then modify the stairs characteristics by clicking on the Select button and selecting the stairs to be modified. For example, we can add landings to the stairs by clicking on the Add Landings button. Next, we will create the second and the third floor of the building by clicking the Copy Floor button. Then we select to copy first floor to every floor above. Let's go to the third floor. The second floor is exactly the same as the first one. In the third floor, first we want to insert the DWG file containing the plan of the third floor. So, we go ahead and click the Import DWG button. In the Open menu we choose the DWG file we want to import from the file list. And we click the Open button. A CAD Settings menu appears and we select Done. Next, we will select the Delete button to remove the existing stair and replace it with a slab. So, we delete the stairs. After, we click the Insert Slab button. Again, the informative window appears. And we click on the closed area to insert the slab. Now we may renumber the slabs by clicking the Renumber button. We assign number 3. And we select the slabs one by one that we want to renumber. We select the Graphical Select button, and we click the slab that we want to modify into an inclined slab. If we check the box enabling the specification of the inclined slab, new fields appear for the 3 points of the slab that will define the slab inclination and their 3D coordinates. We can graphically select each point by selecting the corresponding button. So, let's select point 1. And select it on the floor plan view. Then click to highlight point 2. And select it on the floor plan view. And finally highlight point 3. And click on the desired location of point 3 on the floor plan view. We can go and modify the height of each point in order to create the slab inclination. Here, we will modify the height of point 3. So, we switch from 9000 mm, which is the top of the third floor, to 10,000 mm. Also, we do the same for the next slab. And we select to view the 3D model of the current floor. As final step, we select the button Verify Connectivity. In this way you can check if there is any beam with free span smaller than its section height applied in the model by mistake. And we select Exit and create 3D model. After having built our model we will proceed to the next step of our analysis procedure, which is to define the code requirements for our analysis. So, we select the Code Requirements button on the Procedure Step list. In the first tab we can see the limit states defined by the code. Since all limit states are checked, code-based checks will be carried out for all limit states. Next, in the Seismic Action tab we can define the characteristics and final shape of the acceleration response spectrum. In the Analysis Type tab, we can choose the types of pushover analysis that we are going to carry out. The next tab is the Knowledge Level tab, where we will select the second available knowledge level. Moving on to the Static Actions tab, where we can define the coefficients for the permanent and live loads. Finally, at the Checks tab we can define the types of checks that we want to be carried out during the analysis. We will now move to the fourth analysis step, which is the Eigenvalue analysis. When we click on the Eigenvalue analysis button, the analysis window opens and we just have to click on the Run Analysis button to start running the analysis. When the analysis is completed, a message in the log informs us about this and about the number of the eigenvalues that were found. We can click the Show Results button in order to access the full detailed analysis results. In the first Deformed Shape Viewer tab, we can view the natural periods that correspond with each eigenmode. We can also increase the deformation amplifier. We will now move to the next analysis sub-step, which is the pushover analysis. We click the Run Analysis button to start the pushover analysis procedure. After the analysis finishes, an informative window pops up to inform us about the completed analyses. Now, we can proceed to viewing the analysis results in the SeismoBuild post-processor facility by clicking the Analysis Results button. In the post-processor facility, the analysis results can be accessed using the various available modules. We will move on the next analysis stage, which is the code-based checks stage. Here, we can access the results from different type of checks distributed in the various tabs of the module. We can view the results in table format and visualized on the 3D view model. Also, we can reveal or hide the result tables. Let us view the members chord rotations checks results. Next, the joints shear forces checks results, the joints horizontal hoops area, and the checks for joints vertical reinforcement area. We will now see how we are going to create the report from our analysis. So, the report window appears. Here, we are going to specify the content of our reports. The first tab concerns the general information of our model. Now, in the Members tab of the report printout options, we may determine the information about the structural member checks that will be exported to the technical report. Similarly, in the Beam Column Joints tab, we can specify the information on the beam column joint checks that will be exported to our report. In the Foundation tab, we can specify the information about the footings, if employed, that will be exported to our report. Finally, in the Detailed Calculations tab, we can select to include in our report detailed calculations of the capacity checks for certain members of our structure. And select OK. The report appears right after the generation is finished. We can then save our report by clicking on the Save button, and select the format type in which the report will be saved. Here we will choose to save the report in the standard RTF format. And then press OK to export our report to the RTF file. At a final stage, we click the Export CAD Drawings button. In the window that opens, we can specify various settings on the contents of the drawings. After we are finished, we click the Create Files button. Now our drawings are ready. Let us view the first floor CAD drawing. The drawing contains the floor's plan view, the tables summarizing the columns, and beams reinforcement details, along with the drawings of the columns and the beams cross sections. Congratulations! You have finished your second tutorial.